Hi everyone, I'm Alessandro Benedetti and I'm going to talk about multi-language content discovery through entity-driven search. So, a brief introduction of who I am. I was born in Tarquinia in Italy and I moved to London a couple of years ago. I recently became an Apache Manifold CF committer. I work as a search consultant and R&D software engineer at Zaizi. I got a master in computer science in Italy, in Rome, in 2009, working with a thesis related to information retrieval. Right now, I love to work with semantic, natural language processing, and machine learning related technologies. Last but not least, I'm a beach volleyball player and a snowboarder. So what about Zaizi? Zaizi is a global company, headquartered in the United Kingdom. The main business is oriented to content management system, and the mission is to try to build smart projects related to manage the content, to try to get the best out of the content. We have customers like global enterprises or public sector. The main partner of Zaizi is Alfresco, an enterprise content management system. But the department where I work is the R&D department, and we are specialized in open source search solutions. So today we are going to talk about the federated search solution by Zaizi. But first, let's introduce the Zaizi R&D department. So the main focus of our department is try to give more sense to the documents of our customers. So we want to enrich them and enhance the information they contain. Because we think, of course, that this can be a really important added value to any enterprise content management system. Because, of course, if you have more structure in a content, it's easier to manage, organize, link, and search the content. Because in this way, we can enhance the user experience and make easier the way to find the information the user was looking for. In the enterprise environment, it's really important to have different domains, different data sources to extract the information from. And of course, the user experience is a key point. For this reason, because we wanted to try to extract as much information as possible from the documents, we applied machine learning approaches. So what are the main problems in the enterprise search world? Of course, we have a lot of different data sources because we want to extract the content and index the content from a lot of different places. They can be file system, they can be enterprise content management system, emails, database, and whatever. Of course, we have to deal with unstructured content. So it's really important to be able to extract the content from a lot of different types, so like different formats and MIME types. What about the linking? Of course, we are in enterprise search. In the enterprise search domain, we don't have links across documents. Usually in the web search domain, we have links, but in the enterprise search, we don't have this information, usually. And finally, it's really important to provide a federated search because the user wants to search in a centralized endpoint and find all the information that are located in different original data sources. And we want to search preserving the permissions because, of course, the users need to see only what they are supposed to see. So Sensify is our solution, is a semantic enterprise search engine. It provides federated search, but our main focus was related to user experience. So we were using cutting-edge open source frameworks to provide the user with the best experience we can. So we use Apache Manifold CF to crawl the data sources and index the content. We use Apache Istanbul to provide the enhancements from the content in the documents. We use Apache MAOut to provide machine learning approaches to improve the user experience. We are using particularly classification components to do this. And the core backend component is Apache Solr, of course, to provide the search. This is a brief view of the architecture. So our inputs are a lot of different data sources. We provide the support based on the connectors that Apache Manifold provides. So we can have different data sources in input from different systems. Then, after we crawl the data sources and we get the content, we are going to provide a pipeline processor system that will enrich the contents. Right now, we are using Redlink that is based on Apache Istanbul, but of course, it's possible to integrate any kind of processor we want. And this has been done through customization of Apache Manifold. Then the output, in our case, is Solr, but of course, eventually, it's possible to integrate and index the content with other search engines libraries, like, for example, Elasticsearch. On top of the information we have indexed, we provide a search API that will allow from the user interface to get the advanced feature we are going to show. The important focus we decided to improve our system was to move from keywords-based search to entity-driven search, because humans usually think in concepts and entities, and not simply with keywords. How can we do this? We have to process the unstructured text at indexing time. We have to enrich it, so we have to add more information out of the original content of the document. And then we can build specific indexes in Solr to leverage this information. After that, we can provide the users with entities and concepts in the searches. So what is an entity? From a human point of view, it's quite clear that entities are real-world concepts. But what about a machine? So we need the machine to be able to understand the entities. For this reason, we can use linked data resources and the RDF standard to model real-world concepts in a machine-readable way. RDF is an XML structured data that will provide the description of a unique resource that can be an entity. So we have a unique identifier plus the properties of the entity. The RDF resources are stored in knowledge bases. We have different examples currently of open data knowledge bases. For example, we can have Freebase, that is the Google one, DBpedia, that is based on Wikipedia corpus. And each company can have their own custom dataset. So in this way, we can model the Apple concept to be a fruit with all the details that can be useful for a machine to understand these concepts. How we can enrich the content? We use the Redlink Platform that is based on free Apache solutions. So it's based on Apache Stumble to provide the semantic enrichment. It's based on Apache Marmotta to provide the linked data management, and on Apache Solr to provide the search backend. In this way, we are able to process the text, analyze the text, then identify the relevant concepts and link these concepts to the knowledge base. So, starting from Apache Manifold CF customization, we are able to enrich the content in a processor pipeline. So we move from the unstructured of any kind of document to a structured model of it. We process the document with natural language processing analysis, with part-of-speech tagging, then named entity recognition to identify the relevant parts and tag in the text related to named entities. And then we can proceed with the entity linking to the knowledge base we have configured. And finally, in the last step, we can disambiguate the entities, because of course, from the same label, we can have different matches. After we have finished this process, we are going to index this information in different Solr collections. So we have a primary index with the original documents, so with the fields extracted, so from the metadata extracted from the original data source, plus some field enriched from the document. Then we have the entity index that will contain the entities extracted from the knowledge base, and the entity types that is a support index to provide our search features. The first feature I'm going to describe today is the smart autocompletion. So everyone knows what is the autocomplete, but we try to go a little bit further to provide a multi-phase suggestion in the way that we are going to try to be closer to the natural way a human can build a query. The suggestion that will be shown will be named entities, will be concepts, so entity types, and finally, the title of the documents we have in our index. The first part, so related to the named entities suggestion, we offer infix suggestion. So we are not matching only labels starting with the part of text the user was typing, but also starting in each token of the entity label. We provide fuzzy suggestions, so of course if you do some misspell, it's possible to retrieve the named entity. In return, we get a brief description of the suggested entity and then the list of documents that are relevant for the entity. To provide this, we have, of course, a specific schema for the named entity index. We use a token filter based on the edge engram token filter on the label of the entity. And then we build fuzzy queries with a variable distance from the original typing. For the entity types, we are going to provide the same from the point of view of infix and fuzzy suggestion, but then we provide multi-language, so the user can express the concept and the entity type in his own language, and the system will be able to identify the concept, so the knowledge base resource related to that concept. Furthermore, we're going to provide a multi-phase suggestion through the properties of the entities, in the way the user can build queries more advanced. Also, in this case, we are using a specific Solr index with specific configuration for the schema and Solr config, and the edge engram for the labels of the type. And for the multi-language suggestion, we are using the highlight component in a specific way. Of course, we have to configure this because it's not possible to have it simply by magic. So you have to specify the knowledge base you want to use, and you have to specify the properties of interest for the entity types of interest. Then, automatically, the system will provide this configuration for all the children of that entity type, for example. So if you are interested, as example, in the nationality and in the birthplace of the person entity type, you can configure only the person entity type and the two properties, and then automatically all the subclasses of this entity type will inherit this. So like football players, athlete, actors, every resource that is a person. After that, when the user accepts the suggestion, we can provide advanced search. Like, for example, give me all the documents related to a particular actor, like Christian Bale, all the documents related, so about football players, for example. And finally, we can search by entity type plus properties. So we can have something like, give me all the documents about football players whose nationality is British. And to reach this, we are using right now the query time join between the entity and entity types index and the primary index. Then we provide automatically calculated semantic facets to allow the user to easily navigate the documents retrieved using the semantic information we have extracted. To build this, we built a custom layer in our Search API architecture on top of the Solar faceting component. The last feature I'm going to show, because later I will show a demo, is the semantic more like this. So if the more like this is a component in Solar that will provide you to find similar document to a seed one, the semantic more like this will try to do this not based on text tokens, but based on concepts. So in this way, we can provide multi-language, and we can give better results for a human. To do this, we are using the entity frequency, divided the inverted document frequency, and the entity type frequency, divided the inverted document frequency, inside the documents and inside the corpus. So let's show a quick demo to understand better our system. So this demo is based on a corpus of a couple of hundreds of documents. And these documents are in different data sources, and there are different users. So we don't have time to show that each user will see only a subset of the documents, but it's not important for the demo right now, because what I want to show you are the main features, so the smart autocomplete and the semantic more like this. So when the users start to type, the system will try to guess the entity the user was thinking about. So typing Bale, or eventually, of course, with some error, like Bale, the system will provide you the suggestion. Let's see first the name entities. So for Bale, the system will say you, maybe you were looking for Christian Bale, the actor, or eventually Gareth Bale, the soccer player. So the corpus of documents for this example were like 200 documents about football, about sports, about movies, so video games, a generic corpus. So let's start with the Bale example. So the user accepts the suggestion of Christian Bale, so he was looking for the actor. So the system will retrieve only the documents related to Christian Bale, the actor. In this example, we have like a couple of documents about, one is about Batman and another one about another movie from Christian Bale. If we switch the selection, so if we select the football player, we are going to find a different document, and in this case, it's about like the World Cup. Why this approach is quite important? Because if we move simply to the token, so the keyword search, so we search only Bale, the system will provide all the documents about this token. So this is the classic search, and the system doesn't know which entity you were looking for. Because we are domain independent, if we switch to another domain, so for example, inside the football domain, so we type for Ronaldo, or eventually making also some error eventually, we're going to have two different entities, and both of them are football players. So in this case, if we select the first, so the Portuguese one, we have a subset of documents about Cristiano Ronaldo, so the current football player that is playing for Real Madrid. If we select the other one, so the Brazilian one, the former football player, we get another subset of documents. And if we go simply to the keyword search, we get both. So it's quite easy to understand that for a user that was looking for one specific entity, so for one specific football player, it's quite important to be able to have a difference between both of them. And this was the first block of suggestion, so the named entities. Let's go now with the second block, so the entity types. So if I start typing actor, the system will suggest you as entity types film actor, TV actor, theater actor. If we accept the suggestion for film actor, first we are going to filter the documents. So we got 131 documents related to film actors, so like the box office, Captain America, Lunchbox director on India's new taste for realism, Wolverine 3, and blah, blah, blah. And then we can go further in the properties of the film actor concept. So like, I'm curious of American. So I was looking for documents about American movie actors. So in this way, we filter the documents. And if we want to see for each document, what are the entities, in this case, related to American movie actors, for the Captain America document, we can find Chris Evans, Scarlett Johansson. In this other document about X-Men, we can find, okay, it's not only about X-Men, but something related. We can find like Jennifer Lawrence. But maybe we were looking for another nationality, so for example, Australian film actors. And in this case, we will find Wolverine, because we have, of course, Hugh Jackman inside. But why multi-language? Because in this example, I have only English document, but if I express the concept of film actor in my language, so in Italian, so like attore cinematografico, we are going to find the same subsets of documents because the system will recognize the entity type I typed as the same concept, so the film actor. If I move to French, for example, with acteur, we are going to find the same subsets of documents, the same for football player. We can go with football player, and we find 69 documents. We can go with soccer player, the same. We can go with Ogador, the football, and we're going to find the same. So let's move to the third part of our suggestion block. So like box office, in this way, we simply get the title. So this is quite simple, but quite effective because we can search and get the suggestion directly from the document titles and select the document. the second part that I want to show you, of course, on the left you have the semantic facets, so like with the actors that are in this document. So let's move like to a most generic query. You can have like the actor, the actor with most occurrences, the town in the documents, the countries, and all the entities we have extracted. But if we go again to the box office, we are going to see how the semantic monadics work. So starting from this document, so like a Captain America Winter Soldier box office milestone, if we look for similar documents, the most similar documents are Captain America, another document about Captain America, another document about Chris Evans, because they are sharing entities and they are sharing entity types, because they are sharing like movie actors, they are sharing specific movie actors. If we decrease the precision, we can have like documents about Bruce Lee, for example, Wolverine, Star Wars. So we are really close to the initial concept that is like a superhero movie if we retrieve like another superhero movie or a Star Wars document or these kind of things. And this is independent of the language and of the domain. So if we switch to football, so let's go like to one Ronaldo document. So like Ronaldo, the Brazilian one, we have only a couple of documents. And if we look for similar documents to this one, this is the seed document, the first one. And the most similar is another one about Ronaldo phenomenon in every sense. So initially, with high precision, we are not finding the documents about the other Ronaldo, so the Portuguese one. They are sharing probably a lot of tokens, a lot of terms, but not the same entity that is the Brazilian football player. Indeed, if we decrease the precision, other football article will be shown. So like the Gareth Bale article, a Roy Hodgson, English player, blah, blah, blah article, and then also the Cristiano Ronaldo's one, because they are in the same topic, because they are all about football. So I think we are running out of time, so let's quickly see. So what's upcoming? We want to introduce machine learning components to add classification of our documents, topic annotation, and clustering to give an improved user experience even more. Then we want to provide secured entity search, because maybe not all the users should be able to see all the entities, because the permissions are quite important. Then we are going to introduce also image and media searches, advanced geo search, personalized and collaborative search, recommendation, question and answering, and advanced configurable admin dashboard. So now we have a few minutes for the questions.
Which component or components are you using to do the actual translation? So if I enter something in French, what component is turning that into English or Italian on the back end?
Okay, so the question is like, what component we are using to provide the multi-language feature. So in this case, we were using as an enrichment knowledge base, Freebase, that is the Google knowledge base. Freebase is already offering to the users the possibility of getting international labels, so multi-language labels from entities and entity types. So in this case, we were able to extract the labels from all the languages supported by Freebase, index them, and then index them in the same entity type, in a way that when we search for that label, the system is able to recognize it as the same entity type, because in the index, of course, the entity type has its unique ID and is a specific, unique content. Yeah, because we have, so okay, the question is generic, like how we do this. We have our indexes, so one index for the entities. So let's assume the first feature. So when we suggest a named entity, we search in this index for the entities that are relevant to the text the user was typing. We filter those entities, and then with the query time join, we retrieve the documents that were linked to the entities. Yeah.
So you convert the entities into entity types, and then the entity types are tagged to the documents.
So the entity types are related to the entities, and the entities are related to the documents. Okay.
The entity type is what provides the language disconnect.
Yeah, exactly. Because for the entity types, so the entity types index is what is providing the multi-language labels and also the attributes, so the properties of the entity types. As we have seen in this example, we had like for the person, the nationality and the birthplace. And so those attributes are inside the entity types. So in the way that you can ask the entity types, for these specific entity types, what are the attributes that we can offer to the suggestion? I don't know which was first, maybe you. Sorry. So can you repeat? What about tokenization? Yeah, the question is related how we manage the different analysis for different languages. So in this case, we should say in two places, because we manage this Solar side with the configuration in the schema, but also in the semantic enrichment system that we have, that when I was talking about Apache Istanbul, through Redlink, that is the product on top of Apache Istanbul, they have their configuration to be able to process and enrich different languages.
How do you handle when concepts are introduced to the system? Do you go back and re-index or process or deliver content?
So in which case?
When new concepts are added, like you've got new entity or new entity types, you already have processed the existing documents, and you go back and maybe
So if you, so the question is related if new entities are added to the knowledge base. So if you want the new entities to appear in your system, you have to re-go with the processing of the documents, because of course, if new entities are added to the knowledge base, if you don't process again the text of the documents, you don't know if that new entity was or not in the document. So in that case, yeah, we have to go with the reindexing if you are interested, like in an update on the knowledge base. Or eventually, if you change the knowledge base, in that case, of course, you have to provide a reindexing, because now the entities are completely different. So, okay. Yep.
How do you guys deploy this at a customer site? I mean, I buy the Sensibuy application. Is this run in the cloud somewhere? Installed locally?
So the question is like, right now, if we are offering like in the cloud installation or on-premise, so Sensify has not been released, so far we have no customer for this, but it's based, the prototype is based on a Solar instance, of course can work with Solar Cloud. Probably the intention is like to provide on-premise for the customer that want on-premise, or the cloud version. Because right now, yeah.
Just a follow-up, so it looked like for your processing, you had really complex.
Okay.
How does like customer managing those, or you managing them?
So related to the processing, so related to the enrichment, Redlink is using Apache Istanbul, and this service is already in the cloud, so it's a service. So it's a platform that is already there, is in the cloud. Related to the indexing, because right now it's like a prototype. We simply went like on-premise, so with local installation of a machine manifold. Yeah, and that's it. So we are finished. So thank you, everyone.